Hello everyone, welcome back to our channel. Today we are on a very complicated topic, complex numbers roots, the m roots of the complex number equation. It's very hard, okay, but I'm sure after you do some exercise and reading our video, I'm sure you can do it, okay. Let's go. It is additional higher level, so very complicated. So first, it's not that hard topic first. It's about quadratic equation. We open the room for complex number, but we have still some rules for it. Okay, if the quadratic equation with real coefficients, we have some pattern window. If a complex number set p plus qi is a root, then its complex conjugate p minus qi must be a root also. It's a very important and useful tool. If z is a root, then z bar is also a root, given that the quadratic equation has all real coefficients. How to prove it? It is a proof. It is a fascinating proof. You need to prove on two sides, okay? One side is if real coefficient, then z and z bar must be the roots at the same time. Or reversely, we have to prove if z and z bar are roots for the quadratic equation, then their coefficients must be real. So must be on one side, from left to right and then from right to left. And then we can prove this statement. We call it if and only if. Okay. So the proof is here, for the roots is here. You substitute to all the things because it is real, then we have a lot of calculation, discussion, okay, and then we say that p minus qi is also a root, okay. Excellent. Conversely, what we do is assume z and z bar are roots, okay? And then we reform the quadratic equation and we'll find out all the coefficients are real, okay? Minus 2p, p squared plus q squared, all are real, okay? Excellent proof, okay? But we seldom need the proof in IBDP. Even in paper 3, what we need to do is to use them. Okay, for example, a quadratic equation has a root 4 minus 5i. Find the equation. Don't give the hints to others, okay? You know how to do it, okay? Pause the video and work on it, okay? I have confidence on you. Welcome back. Just use the rules, right? Assume it is a real, okay? Coefficient, okay? So this is the root. So its complex conjugate 4 plus vi is also a root. So you got all the two roots actually. Yeah, so x minus them, multiply together equals 0 is the equation. Expand them, simplify them. So x squared minus 8x plus 25 is equals 0 is the equation. And you can see all the coefficients are real. 1, -8, and 25. You got it? Yes, so remember the rules, okay? Next, the complex roots of polynomial equation. Now we go further, not just quadratic, cubic, fourth order, or whatever. Okay, so we think about first roots is very important. Order of a polynomial equation is number of roots, okay? Quadratic order two roots, cubic 3 roots, x fourth 4 roots, and whatsoever, okay? So first we use summation notation to represent a polynomial equation. Do you remember it's a polynomial? It's a summation an xn, and n starts from 0 because we want to include the constant term. And the last one is n, the order is n, okay? So altogether there is n plus 1 terms, okay? And it equals 0, so it's a polynomial equation. And we said that it has n roots, okay? And now the same rules apply if all the coefficients are real, okay? If a root, a complex number is a root, then it's a complex conjugate is also a root, okay? And what we do is, because the polynomial may have a lot of higher order, so we do these factors, okay? And we are sure that fx is divisible by this factor, so we really divide it by log division and find out gx. And gx sometimes will be reduced to a second order, okay? So before fx is a fourth order. Second order equation equals 0 quadratic. You can solve it, okay? So you can solve a fourth order polynomial equation given one complex root to you. Very powerful, right? So also if it is an odd order polynomial equation, then you must have at least one real words, right? Because the odd one, single one more words, okay? That one can't have a partner, so it is not a complex number. It's just a real number. So solve this equation, okay? You can do it. Thinking, and you win. Welcome back. Or you thought about it, maybe you can do it, and actually if you can't do it, you don't know how to do it, but you think about it, you got some experience already. Because in examination you always think, okay? So you need this experience of thinking. It will speed up your thinking, okay? So remember not two words. You get all the four words, okay? And these all four words multiply together and it becomes S, okay? Remember the rules, okay? So we got all the four words, and all the four words come multiply together will be S, okay? If it is cubic, of course, the negative will become negative S, okay? So be careful if it is odd number. You got it? Well done. De Moivre's theorem is very important. When it's a theorem about a complex number, they said that the nth power of a complex number, its argument will be multiplied by n. Why? It had a rigorous proof, but we don't do it here, okay? It's just a theorem to us we use. Okay, it said that a complex number set, ours is theta, is the power n. Very easy to do. So it's just r to the power n is n theta. Just multiply its argument by n. Why? Yeah, it's a good question, but it is proved by mathematical induction. Okay. So we can also expand the left hand side, right? And then we'll have real parts and imaginary part. Right hand side also have real and imaginary part. If we equate the real part of the two sides and the imaginary part of the two sides, you can fairly funny. You can got some identity of sine and cosine. Sine cube theta, sine phi theta, cosine phi theta, sine 4 theta, cosine 4 theta. Very powerful. De Moivre's theorem. Excellent. It's also applicable for rational number n equals a p over q. We can do the same thing. Really the same thing. And also remember, because the rules is for cis, it must be cosine theta plus I sine theta. So if you're given cosine theta minus I sine theta, remember to change it to here first. Cosine negative theta plus I sine negative theta first. Okay, try to use the De Moivre theorem to simplify this way. Rigorously, okay? Welcome back. I'm sure you got the result, but did you remember to change it to plus first? If not, then you will lose some procedure marks, okay? Because the rules, De Moivre theorem is really for plus I, cis, cosine theta plus I sine theta, not for negative, okay? Be careful. Although the result is the same. You have the temptation to jump from the first to the last, but be careful. Control it, okay? Okay, the other concept is the n fruits of a complex number. Remember the n fruits, okay? So reversely, power n is multiplied by n, right? Then the n fruit is easier. Just the argument is theta over n, right? But be careful, it's just the first word. The n word. You have n words. How about the other n minus 1 word? How can you find it? Okay, that is the question, okay? So you have a set n here. And you find out n is a cis theta, it says it's phi to the power n, so it becomes an cis m phi. And you know that these fingers can be equal to r cis theta plus 2k phi, because 2k phi are the same, right? A cycle, okay? So you divide both sides by n, okay? So in order to find the answer will be theta, it's the angle, initial over n, and then plus 2k pi over n, 2k pi over n plus b over n. What do I mean is the general solution will be theta over n. Yes, but plus something. Theta plus 2 pi plus 4 pi plus 6 pi plus 8 pi over n. Okay, until you got the repeating the same identical words again and stop. And then for this procedure you get n word. Okay, n word. Although if there is some constraint on the argument of set, okay, then some words may be rejected. Okay. We have theta plus 2k pi over n, or theta plus 2 pi over n, plus 4 pi, plus 6 pi, plus 8 pi, until go back, okay, plus n, 2 pi, n minus 1, okay. So see what happens. Okay, solve this equation. Yeah, you know that there are 5 words, right? 5 words, but for the argument, there's some constraint. Maybe not all the 5 words are allowed. So you got to think, okay, it should be 0, so before is 0. So theta is 0, theta over n is 0 too. So the first one is 2 pi over 5, and then 4 pi over 5, 6 pi over 5, and then next is 8 pi over 5. Oh no, x pi over 5 is larger than 3 pi over 2. H over 5 is larger than 3 over 2. Yes, then you have to stop there. You got it? Well done. And then you also represent this n foot in the eigenplane. Actually, this n foot, okay, divide the eigenplane evenly into n parts. Okay. Yes, each one is separated by 2 pi over n. Okay. So by this one, for example, we just make it easier. So set n equal 1. Okay, because we want to choose r equal 1 and theta equal 0 for a better equation. That's if it is a theta, then you have to rotate it integralize it by the theta over n. Okay, it's symmetric. Okay. And then you find out all the plane is divided by 2 pi over n. Okay. N parts, okay? And then you find it out where Z1 is Z minus n minus 1's complex conjugate refracted along the x-axis. And for this one, Zn equals 1, there's another funny thing. So you move thing to the left-hand side. Zn minus 1 equals 0, and you can factorize it. What? By Zn minus n 1 times Zn minus 1, Z minus n minus 2 plus 1. So if this is the root, okay, and the Zn is also the root of this long equation, it means that if a Z cube minus Z cube equal 1, okay, it is the root is also Z squared plus Z plus 1's root too. Very funny result, okay. And we can also find out this triangle's area, half AB side C, right? And the C is 2 pi over n, and the AB is 1, because it's half side 2 pi over n. And then can you sketch this with on the Argand diagram? Welcome back. Did it? Yeah, divide evenly into 7 parts. Okay. And each part is separated by 2 pi over 7. For this part, I recommend you not to use 2 pi, you 360 degrees over 7, and then you multiply, and then you visualize where is it approximately. Is it over 90 degrees, or is it not existing 180 degrees? It will be easier to see if you use a 360 degrees. And then how to solve other equation of complex variable? Very easy. Change to this form. Zn equals Z1. Yes, I remember. Change to this one, then this is the n foot problem, right? Theta plus 2k pi over n. Yeah. Let's change it, okay. And then also change this one to Z1. This is why we need to learn it. We learned it before, okay? How to change a number, a complex number, into the form of Z1 in the Euler form. Okay, solve this equation, okay. Try to do it. You need to do it. The theory is easy, but when you work on it, it's hard. Really hard, okay. Trust me. Welcome back. Check it out. Yes, you got it. It's negative 8 over 125. You saw it is cube, then you make it cube. Okay, 2 over 5 cube. And minus is cosine pi plus I sine pi, right? So 6 pi. So the first root is pi plus 2 pi, pi plus 4 pi, and pi plus 6 pi. And you list out all the roots. Okay, this entire is some simplification. You got it? Yes. But what you need to do more exercise, past paper, textbook problem. Okay, make sure you remember the rules and you can use it quick. In IBDP exam is quite watch. Okay, and thank you. I'm sure you learned something. I hope so. If you like our video, remember share with your friends and like and subscribe. Okay, see you for next Math A&A Friday. Bye bye.